Hello friends, welcome to our channel. Let's have a look at problem 45, maximum difference between even and odd frequency. This is the second of such problems. This problem is marked hard by LeetCode. So here in this video, we're going to address it using two-point sliding window method, but with the help of bitmask. So here I'm not going to read through the problem statement, but here we want to mention to you the length constraint is like this, and also S consists only digits from 0 to 4, right? So the input is generated such that at least one substring has a character with an even frequency and a character with an odd frequency. So with that said, basically we can explain the idea. So first, we are going to introduce some notation. I'm going to call the character, right? The count of the character in the prefix, let's see, starting from index 0 and ending at index G, be count of character up to and include G. And then the frequency of A in this subarray, see, from beginning at I and ending at G, is this one, count of A up to G, then minus count of A up to I minus 1. So similarly for B, right? So this is some notation. So now let's look at our goal. Our goal is to maximize the difference of the frequencies A and B with parity constraints and over all possible substrings starting from I and ending at G, right? And also has a length constraint that is at least a key. Let's first ignore the constraints and look at this expression, right? So we are going to do some rearrangement to decouple the indices, right? If you just look at this, the frequency A minus frequency B, this is the frequency A, right? So this is the frequency B. If you look at the two blocks, so it both involve I and G. But now if I just do some simple algebra, I put the index G together. It's the count A up to G minus count B up to G. The second block is the counts up to I minus 1. So this realizes the decoupling of I and I minus 1 and G, right? So this is going to be important for us to use two-point sliding window method. Next, we're going to look at how do we do the task. So here, with this expression, all the I and G decoupled, so we could track the quantity of the form, right? The difference with a single index by linear scan. So this naturally introduces us the two-point sliding window method. So basically the idea is for each right index G, so we have this one, right? This is easily done. And then we need to find the smallest or best this quantity, right? Such that in between, so this is the string in between. It has length at least k, this is the length constraint. And also A appears odd number of times and B appears even number of times. So that's the overall principle. So now there are 2 points we need to address. The first is how to find the best this quantity. In other words, the smallest one. So we can use dictionary and check, right? So this is very routine. If you do not know, you can see a prototype problem, that is problem 560. This is the one. Another point is how to check A-B have right parities in the substring, right? So here we can use bitmask. It's very convenient. So here we can use just 2 bits. That will be sufficient. So the 0th bit will represent the parity of B, and the first bit will represent the parity of A. So here let's give you some example. So here we have S, which has length 7, right? So let's assume A is 0 and B is 1, right? So here for the full string, that is from 0 to 6, A appears 4 times and B appears 3 times. So the mask would be, because A appears 4 times, so it corresponds to a 0, and B appears 3 times, it's odd, corresponding to a 1, right? So the mask can be computed like this. So count of A. So we check if it's odd and even. And then we shift to the left one unit, position. This using bit position 1, right? So this is checking B, but using position bit position 0. So similarly, you can see for the same as if I'm consider the prefix ending at index 3. So A and B both appear twice, right? So the mask corresponding to up to here is 0, 0. So now, what's the parities between 4 and 6, right? In between. So here, A appears twice and B appears once. So the bit mask in between should be 0, 1, because 0 means A appears twice, even, right? 1 means B appears odd number times. So this is nothing but the bit mask exclusive all, right? So 0, 1 exclusive all with 0, 0, you get 0, 1. So now comes to this question again. So for right mask, we could find a left mask such that the desired left mask should be the right mask exclusive all with 1, 0, right? So why this is the case? Because which means the desired left mask, then you do exclusive all with the right mask, is going to be this expression. So the two right mask cancels. You have 0B, 1, 0. So this means in between, A appears odd number times and B appears even number times. So similarly, if you consider your constraint is A appears even number times and B odd number times, you should do this 0, 1, right? So still further, if we require both A and B appear even number times, the desired left mask should be right mask bitwise all with exclusive all with 0, 0. Similarly, for A and B require odd number times both, so you have 1, 1. So with this done, went over. So now we can go to the coding part. So you can come back and make a correspondence with this instructions. So the coding would be rather straightforward now. First, let's define a function to get the status, right? Status. So you have a count of character A, a count of character B. So let's see the parity. We want to encode the parity. So this will be so A count or count A. So let me use this to count B. So it would be count A. I'm going to check if it's the parity, and then push it to the left one step. So this using bit position 1. In other words, we're using bit position 1 for the parity of A. And then I'm going to use bit position 0 for the parity of B. So this is just a hyperfunction. So now let's do the problem logic. Introduce this in for the length of S. This is just for convenience. So I'm going to initialize an answer to be a very small number. So float infinity. So because of the requirement, the assumption, right? Finally, we will have a answer which is not negative infinity. So now, because of the problem has only 0 to 4, actually we can fix the two characters and then consider the max. So this is exactly the hint, right? So here, let me see characters. So it's going to be, say, 0. Let me hard code it that. You can use a string, but let's write a list. And then I'm going to iterate, right? So for A in characters and for B in characters. So this has at most, 25 combinations. So 25 is an order of tens. Then times this one is order of 10 to the power fifths. Should be okay, right? So if A equals B, so they're the same, we're going to continue, right? Otherwise, so we are going to do the two-pointer sliding window. But we need to track the best left mask as here, right? So we are going to use dictionary and check. So now I'm going to initialize a dictionary. So that's best. So I'm going to use collections default dict. So I'm going to map everything to be a float infinity. So because we want to find the smallest one, right? The smallest such thing. Smallest this one, right? With the right parity. So now let's look at the setup. So count A, count B, initially 0. And the previous A count of A, previous count of B is also 0, right? So I set the left pointer to be 1. This corresponds to this count. And then the for loop for R in range N. This corresponds to the right pointer. So let's accumulate the count of A. So this is incremented by if the S and R equals A, right? So similarly, count B is if this SR equals B, right? So now let's look at the while loop. So while from the right bound, that is R minus L, because L is not the start. L plus 1 is the start of the immediate part. So this is the length. If this is greater than or equal than K, and the count B minus previous count of B should be greater than or equal to 2, because in the bound B appear. So we require B appears even number of times. So because it's even, it's at least 2, right? So now let's look at the left status or the left mask. So get status. So press A and press B, right? So the best such status will be left status will be this, right? So be mean of best. So because I have using this default, so I can directly call this by without using get method with a default. So best, and then we get press A minus press B, right? So this is the here the quantity we are talking about, right? So with that finished, let's do the pointer sliding. So we shift the pointer to the left. So then we count the previous A. So it's incremented by this one, right? So S and L, whether it equals A, right? So press B, same thing. S, L equals B. So now after this while loop, we are going to try the right status or right mask. It's going to be get status. So using the current count of A, count A, count B, right? Now we use a dictionary and check strategy. So the desired left, so desired status, left status or left mask will be right status exclusive all. Here we require A odd number times, B even number times. So there's 0. So you write 0B, right? So this is nothing but 2, right? And then what we want to do is if best, so the desired status. So we hope it appeared. So if it appeared, it should be less than the default, that is float infinity. Then what we do, we update the answer. So it will be max answer and count A minus count B minus this best at the desired status, right? So that's actually the full logic. So now what we do actually, we can return the answer. Let's the A in S. Let me first do a test to make sure it works. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So that's basically about it for the current coding. So if you want to further digest, there are 2 suggestions. First, you can use the code and play with it and do some prints. That's good. Another thing is that you can do a manual walkthrough using the example with this code. That will give you a deep impression of the logic of this problem. So during the coding, you can come back and forth between the instruction and the coding. So one thing I want to mention is that, so here the decoupling is very crucial for enabling us to use two-pointer sliding window method. And another thing is that we use dictionary and check to do the task. So if you haven't used this kind of trick, you can look at problem 560. So finally, we have a YouTube channel which contains more than 1,000 carefully designed solutions for LeetCode problem, and with lots of playlists. You're welcome to check out and do some practice or share with your friends. With that said, that's it for the current video. Thank you.